In this lecture, we'll prove Stewart's theorem in two different methods. In a nutshell, Stewart's theorem yields a relation between the lengths of the sides of the triangle to its CBN. So here we have a triangle ABC. The length for side AB is C units, side AC equals to B units in its length, and for side BC equals to A units in its length. And the CBN in this triangle ABC, is line segment AD. The CBN is line segment AD, and it is equals to D units in its length. AD equals to D units in its length. We also know that line segment BD equals to M units, and line segment DC equals to N units in its length. Then, according to Stewart's theorem, the following equation is true: that B squared times M plus C squared times N equals to A. We open the brackets. Inside the brackets we have D squared plus M times N. I repeat again: B squared times M plus C squared times N equals to A. Inside the brackets we have D squared plus M times N. So we prove Stewart's theorem in the first method. And in the first method, we do a construction, that is to say, from the vertex A of triangle ABC, we go perpendicular on BC. Okay. So this angle equals to 90 degrees, and this angle equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point A and BC as E. We define line segment ED as X. This is to say, the length of line segment ED is equal to X units according to our definition. We define the length of line segment AE as H. And what is the length of line segment BD? The length of line segment BD from the domain is. What is the length of line segment BM? What is the length of line segment BM? From the drawing it is very easy to see that BM equals to BD minus ED. Again, BD minus ED equals to BM. So I write it down. BD BE equals to BD minus ED. So BE equals to BD equals to M units in its length. You can see in the drawing. So we substitute BD by M. And according to our definition, ED equals to X units in its length. So we substitute ED by X. In conclusion, we found out that B equals to M minus X units in its length. Here, BE, this line segment BE, it is equals to M minus X units in its length. And what is the length of side of line segment EC? From the drawing it is very easy to see that EC equals to X plus N. EC equals to X plus N, so EC equals to X plus N. Write it down here. It is equals to X plus N. Okay, EC equals to X plus N. Okay, In the next step, we'll implement the Pythagoras theorem on the right green triangle, triangle AD. Okay, repeat again, we'll implement the Pythagoras theorem on the right green triangle, triangle AD. And according to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So in the right green triangle AD, the hypotenuse is AD, therefore the square of the hypotenuse is AD squared, and it must be equal to the sum of the squares of the perpendiculars, that is to say, it must be equal to AE squared plus ED squared. Repeat again, according to the Pythagoras theorem, in the right green triangle, triangle AED, AD square equals to AE square plus ED square. Here by PT is representation for Pythagoras theorem. So AD equals to the unit itself, therefore AD square equals to D square, and it is equal to AE square. AE equals to A units, therefore A square is A square plus ED square. ED equals to X according to our definition, therefore ED square is X square. So in conclusion, we found out that in the right green triangle, triangle AED, D square is equal to A square plus X square. In the next step, we'll implement the Pythagoras theorem on the right triangle, triangle AC. This right triangle, triangle AC. In the right triangle AC, according to the Pythagoras theorem, AC square equals to AE square plus EC square. Repeat again. In the right triangle, triangle AC, according to the Pythagoras theorem, AC square equals to AE square plus EC square. This will be equation number 1. So according to equation number 1, AC is B. Therefore AC square is B square, and it is equals to AE square. AE is H, therefore AE square is H square. Plus EC square. EC equals to X plus N, therefore EC square is X plus N square. In conclusion, we found out that according to equation number 1, in the right triangle AC, B square equals to H square plus X plus N square. Here we'll open the brackets on this side of this equation, equation number 1, and we'll get that according to equation number 1, B square equals to H square plus X plus n squared equals to x squared plus n squared plus 2 times xn. Here we have h squared plus x squared, this equation number 1, and we have already found out that x squared plus h squared equals to d squared. So we substitute h squared plus x squared in this equation number 1 by d squared. We do it now and we get that according to this equation number 1, b squared equals to h squared plus x squared is d squared plus n squared plus 2 times xn. So this is equation number 1. B squared equals to d squared plus n squared plus 2 times xn. Okay, so in the next step, we'll focus on the triangle ABE. Again, we'll focus on the pink triangle ABE, and we'll implement the Pythagoras theorem on this right pink triangle ABE. Okay. So in the right pink triangle ABE by PT is a relation from Pythagoras theorem. According to the Pythagoras theorem, AB squared equals to BE squared plus AE squared. Repeat again, the square of the hypotenuse is AB squared, and it must be equals to BE squared plus AE squared. Repeat again. In the right pink triangle ABE, according to the Pythagoras theorem, AB squared equals to BE squared plus AE squared. Okay. So AB is C. Therefore AB squared is C squared, and it must be equal to BE squared. BE is m minus x. Therefore BE squared is m minus x squared plus AE squared. AE is h, therefore AE squared is h squared. In conclusion, we found out that according to equation number 2, in the pink triangle ABE, C squared equals to m minus x squared plus h squared. Here we'll open the brackets on this side of this equation number 2, and we'll get that according to equation number 2, C squared equals to m minus x squared is m squared plus x squared minus 2 times mx plus h squared. Again, here we have h squared plus x squared, h squared plus x squared equals to d squared. So we substitute h squared plus x squared by d squared in this equation number 2, and we'll get that according to this equation number 2, C squared equals to m squared plus x squared plus h squared. X squared plus h squared is d squared, so we substitute x squared plus h squared by d squared minus 2mx. So actually we found out in conclusion that according to equation number 2, c squared equals to m squared plus d squared minus 2 times mx. Well, according to equation number 1, we have already found out that b squared equals to d squared plus n squared plus 2 times xn. So we have those two equations, equation number 1 and equation number 2. In the next step, we'll create equation number 3. And according to equation number 3, we'll actually create equation number 3 in the following way. First of all, we will multiply both sides of equation number 1 by m. So it is m times equation number 1. Then we will multiply equation number 2 by n. So it is n times equation number 2. And then we will add the two equations together. And this will be equation number 3. Okay, equation number 3 equals to m times equation number 1 plus n times equation number 2, and then the addition of equation number 1 plus equation number 2. Okay, each equation has two sides. Yes, so first of all, we will multiply the right side of equation number 1 by m, then we will multiply the right side of equation number 1 by n, and we will add the two equations together, and then it must be equals to the multiplication of equation number, the left side of equation number 1 by m plus the multiplication of equation number 1 on the left side of equation number 2 by c, and then we will add the two equations together. Okay, so we start by multiplication of equation number 1 by m, the right side of equation number 1 by m. So it is m. In the right side of equation number 1, we have d squared plus n squared plus 2 times xn. And then we will multiply the right side of equation number 2 by n. So it is n. And in the right side of equation number 2, we have m squared plus d squared minus 2 times mx. So we added the two equations together. And then it must be equal to the multiplication of equation, the left side of equation number 1 by m. So it is mb squared plus the multiplication of the left side of equation number 2 by n. So it is n times c squared. Okay. In the next step, we'll open the brackets on this side of equation number 3, and we'll get that according to equation number 3, m times d squared is md squared plus m times n squared is mn squared plus m times 2xn is 2xmn plus n times m squared is nm squared plus n times d squared is nd squared plus n times minus 2mx is minus 2mxn. Okay, it is minus 2mxn. So this is equation number 3 after we opened the brackets. Okay. Here we have 2 times xmn plus 2 times xmn minus 2 times xmn equals to 0. So those two expressions will get cancelled. In the next step, we will take this, we'll take out d square as a common factor from this expression and also from this expression. So d square is a common factor, is taken as a common factor. Inside the brackets here, after we took d square as a common factor, we will have m. Plus, after we took from this expression d square as a common factor, we left only with n inside the brackets. In the next step, we take out mn as a common factor from this expression, and we'll also take out nm as a common factor from this expression. So here mn is a common factor. Inside the brackets, what is left from this expression after we took nm or mn as a common factor? What is left is actually m. What is left from this expression after we took from it mn as a common factor? What is left is actually n. And we also have here it is equals to, this is equation number 3. According to equation number 3, this is the left side of equation number 3. This is equals to the right side of equation number 3. In the right side of equation number 3, we have mb square plus nc square. So it is equals to mb square plus nc square. Okay, I just forgot to copy those two expressions in equation number 3. So equation number 3 equals to these expressions, and that is equals to this expression mb square plus nc square. Okay. In the next step, we take out m plus n as a common factor from those two expressions. So we have here m plus n was taken out as a common factor from those two expressions. Here we left only with t square, and in this expression we left only with m times n. And it is equals to b square m plus c square n. According to this equation, equation number 3. Here we have, it's very easy to see from this drawing that m plus n equals to a. Okay, a equals to side BC, and side BC also equals to BD plus DC. BD plus DC is m plus n, that is equals to BC, that is a. So we can substitute m plus n in equation number 3 by a. Okay, m plus n equals to a, so we substitute m plus n by a in this equation, equation number 3, and we get that according to equation number 3, a, we have d square plus mn equals to b square m plus c square n. And this is exactly Stewart's theorem. So we proved Stewart's theorem according to the first method. In the next step, we'll prove Stewart's theorem according to the second method. In the second method, we define this angle ADC, angle ADB. This is angle ADB. We define angle ADB as theta. And therefore, this angle must be equal to 180 degrees minus theta, according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. BC is a straight line. The sum of the angles on the upper side of BC at point D must be equal to 180 degrees. Here, 180 degrees minus theta plus theta equals to 180 degrees. Exactly according to rule number 1. Okay, in the next step we will implement the law of cosines in this triangle, the green triangle, triangle ABD, and we will also implement the same law, the law of cosines, in the pink triangle, triangle ADC. Okay. I will remind you what is the law of cosines. The law of cosines is true in any triangle. So we have the triangle that I will draw could be any triangle. This is triangle ABC, that could be any triangle. We know that the length of side AB in triangle ABC equals to A units, side AC equals to B units in its length, and finally side BC equals to C units in its length. In addition, we also know that angle BAC equals to theta in its size. So this equation, in this triangle ABC, that could be any triangle. The following equation is true, that C squared equals to A squared plus B squared minus 2 times A times B times cosine theta. Here we will add 2 times AB cosine theta to this equation, and then we will subtract C squared from this equation, and then we will divide this equation by 2 times AB, and we will get finally that cosine theta equals to A squared plus B squared minus C squared over 2 times AB. Okay, this equation is true in any triangle. Therefore, we will implement the law of cosines in the green triangle, triangle ABD. So, according to the law of cosines in the green triangle, triangle ABD, we get that cosine theta equals to d squared plus m squared minus c squared over 2 times dm. So here, equation number 1 is the implementation of the law of cosines in the green triangle, triangle ABD. Cosine theta equals to here, d squared plus m squared minus c squared over 2 times dm. In the next step, we'll implement the law of cosines in the pink triangle, triangle ADC. So in the pink triangle, triangle ABC, triangle ADC, according to the law of cosines, we'll get that cosine 180 degrees minus theta equals to d squared plus n squared minus b squared over 2 times dn. Here, equation number 2 is the implementation of the law of cosines in the pink triangle, triangle ADC. Okay. cosine 180 degrees minus theta equals to d squared plus n squared minus b squared over 2 times dn. According to the algebraic, to the trigonometric identity, we know that cosine 180 degrees minus theta equals to minus cosine theta. So we can substitute cosine 180 degrees minus theta in this equation, equation number 2, by minus cosine theta. We will do it now. And we will get that according to equation number 2, cosine 180 degrees minus theta is minus cosine theta. And it is equals to d squared plus n squared minus b squared over 2 times d times n. Okay, in the next step, we will multiply this equation, equation number 1, by minus 1. And we get that according to this equation, equation number 1, cosine theta times minus 1 is minus cosine theta. And we'll multiply also this side, equation number 1 by minus 1, so it is minus. Inside the brackets we have d squared plus m squared minus c squared over 2 times d times m. Okay, so this is equation number 1. After multiplied by minus 1. And according to equation number 2, we have already found out that minus cosine theta equals to d squared plus n squared minus b squared over 2 times dn. In the next step, we'll create equation number 3 that states that minus cosine theta according to equation number 1 must be equal to minus cosine theta according to equation number 2. Okay? So according to equation number 3, we'll get that minus cosine theta according to equation number 1 is minus d squared plus m squared minus c squared over 2 times dm, and it must be equal to minus cosine theta according to equation number 2. Minus cosine theta according to equation number 2 equals to d squared plus n squared minus b squared over 2 times dn. Here we'll multiply this equation, equation number 3, by 2d. And we'll get that according to equation number 3, two d over 2d is 1, so 2d will get cancelled, and then the denominator will left only with m. In this side of equation number 3. We have d in the denominator. The numerator didn't change. So it is minus d squared plus m squared minus c squared. And it is equals to multiplied also this side of equation number 3 by 2d. Again, 2d over 2d is 1, so 2d will get cancelled. And in the denominator, we left only with n. And the numerator didn't change. It stays d squared as d squared plus n squared minus b squared. In conclusion, we found out that according to equation number 3, minus d squared plus m squared minus c squared over m equals to d squared plus n squared minus 3 squared over n. Here we cross multiply this equation number 3, and we get that according to equation number 3, minus n, inside the brackets we have d squared plus m squared minus c squared, and is equals to m, inside the brackets we have d squared plus n squared minus b squared. Here we'll open the brackets on both sides of this equation number 3, and we get that according to equation number 3, in this side of equation number 3 we have minus n times d squared is minus n d squared, minus n times m squared is minus n m squared, and finally minus n times minus c squared is plus n c squared. Why? Because minus times minus is plus. So it is plus n c squared, and it must be equal, we'll open the brackets on this side of equation number 3, and we get that m times d squared is m d squared, plus m times n squared is m n squared, plus m times minus b squared is minus m b squared. Okay, in the next step we'll add to this equation n d squared, equation number 3, n d squared, and also we'll add n m squared, and we will subtract n c squared. Therefore, in this side of the equation we're left with 0. Okay. In the other side of equation number 3, we have here md squared plus mn squared minus mb squared, and we added nd squared to this equation, so it is plus nd squared. We added also nm squared to this equation, so it is also plus nm squared, and we subtracted nc squared, so it is minus nc squared. Okay. In the next step, we'll take this square, we'll take out this square as a common factor from this expression and from this expression. So this square was taken out as a common factor from this expression. Therefore, inside the brackets we left only, it is n d squared. So inside the brackets we left only with n. We took out it is actually md squared. Okay, we took out this square as a common factor, so inside the brackets we left only with n. And then we took out this square as a common factor from this expression, so inside the brackets we left with n. So in conclusion, we found out that this square m times n plus n, and then we take mn, we take out mn as a common factor from this expression and from this expression also. So nm or mn was taken out as a common factor from this expression, nm squared. Therefore, inside the brackets we left only with m, plus mn was taken out as a common factor from this expression, mn squared. Therefore, inside the brackets we left only with n, and it is minus m squared. It is minus mb squared minus nc squared is equal to 0. In the next step we will add mb squared plus nc squared to this equation number 3, and we get that according to equation number 3, d squared m plus n plus mn m plus n equals to, here we added mb squared to this equation, so mb squared minus mb squared is 0, and here 0 plus mb squared is mb squared. We also added nc squared to this equation, so nc squared minus nc squared is 0, so in this side is relative 0, and here 0 plus nc squared is nc squared. Okay, in the next step we'll take m plus n, we'll take out m plus n as a common factor from those two expressions, and we'll get that, so m plus n is taken out of those two expressions as a common factor. Here inside the brackets we left only with d squared, and here inside the brackets we left only with m times n, and it is equal to b squared m plus c squared n. We have already found out that a equals to m plus n, therefore we substitute a by m plus n. So, according to equation number 3, so m plus n is a, inside the brackets we have d squared plus mn, and it equals to b squared m plus c squared n. Okay, repeat again. We substitute m plus n by a, so it is a d squared plus mn is equal to b squared m plus c squared n. And this is exactly Stewart's theorem. So we proved Stewart's theorem in two different methods. In the next step we'll summarize the lecture. We'll start with the first method, of course. So, in this lecture we proved Stewart's theorem in two different methods. In a nutshell, Stewart's theorem yields a relation between the length of the sides of the triangle and the serian of the triangle. Here we have this triangle ABC could be any triangle. The length of side AB is C units, the length of side AC is B units. Side BC equals to n units in its length, line segment BD equals to m units, line segment DC equals to n, and the CBN in this triangle ABC is line segment AD. And the length of the CBN AD is D units in its length. So according to Stewart's theorem, the following equation is true: that b squared times m plus c squared times n equals to a, and we open brackets, inside the brackets we have d squared plus m times n. Again, b squared times n plus c squared times n equals to a, inside the brackets we have d squared plus m times n. So we proved Stewart's theorem according to the first method. Here we did the construction from point A, we draw perpendicular on BC. So this is, let's say this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. We define the touching point of the perpendicular for vertex A and BC as E, and then we implemented the Pythagoras theorem on the green right triangle AD. In the green right triangle AD square equals to AE square plus ED square. We defined ED as x, AE is defined as h, and here it is very easy to see that EC equals to x plus n, and here line segment BM equals to BD minus ED. BD is M, ED is x, so line segment BE equals to M minus x. So we implemented the Pythagoras theorem on the green right triangle, triangle AED. According to the Pythagoras theorem, in the green right triangle AED, AD square equals to AE square plus ED square. I'll repeat again. In the right triangle, triangle AED, AD square equals to AE square plus ED square. AD is D, therefore AD square is D square. AE is H, therefore AE square is A square. And finally, ED is X, therefore ED square is X square. ED square is X square. So in conclusion, we found out that D square equals to H square plus X square. Then we focused on triangle AEC, on this triangle AEC, triangle AEC, this triangle AEC. We implemented in this right triangle AEC, the Pythagoras theorem. According to the Pythagoras theorem, AC square equals to AE square plus EC square. Repeat again, AC square equals to AE square plus EC square. AC is B, therefore AC square is B square. AE is H, therefore AE square is H square. And finally EC is X plus N, therefore EC square is X plus N square. So we conclude found out that according to equation number 1, B square equals to H square plus plus X plus N square. Again, B square equals to H square plus X plus N square. Then we open the brackets on this side of equation number 1, this equation number 1, and we found out that B square equals to H square plus X plus N square equals to X square plus N square plus 2 times Xn. H square plus X square equals to D square according to this equation, so we can substitute H square plus H square in this equation number 1 by D square. We did it, and we got that according to equation number 1, B square equals to H square plus X square is D square plus N square plus 2 times Xn. So according to equation number 1, we found out that B square equals to D square plus N square plus 2 times Xn. Then we focused on the pink triangle, triangle AEB, and we implemented the Pythagoras theorem on this pink triangle, triangle AEB. According to the Pythagoras theorem, AC square equals to AE square plus BC, but AC square equals to AE square plus BE square. Repeat again, in the pink triangle, triangle AEB, AD square equals to BE square plus AE square. AB is C, AE is H, and CE is M minus X. Therefore, we get that AB square is C square, BE square is M minus X square, and AE square is H square. Therefore, C square equals to M minus X square plus H square. If we open the brackets on this side of this equation number 2, we found out that C square equals to M minus X square equals to M square plus X square minus 2 times MX plus H square. Here, H square plus H square, according to this equation, this equals to D square. So we substituted H square plus H square in this equation number 2 by D square. And found out that according to this equation number 2, C square equals to M square, and X square plus H square is D square, minus 2 times MX. And according to equation number 1, we already found out that B square equals to D square plus N square plus 2 times Xn. In the next step, we created equation number 3, by multiplying equation number 1 by m, then we multiplied equation number 2 by n, and we added the two equations. In this way, we created equation number 3. So, we multiplied the right side of equation number 1 by m. So it is m, inside the brackets we have d squared plus n squared plus 2 times xn. Then we multiply the right side of equation number 2 by n. So inside the brackets we have n, and inside the brackets we have m squared plus d squared minus 2 times xm. Okay? And it must be equal to the multiplication of the left side of equation number 1 by m. In the left side we have bm, and so when we multiply it by m, it will be mb squared plus the multiplication of the left side of equation number 2 by n. In the left side we have c squared, therefore it is n times c squared. Okay, in this way, this is equation number 3. We open the brackets on both sides of this equation, equation number 3, and we found out that according to equation number 3, we have m times d squared is md squared, m times n squared is mn squared, and m times 2xn is 2 times xmn. Here it is plus m times m squared is nm squared, n times d squared is nd squared, and finally n times minus 2mx is minus 2xmn. So this is equation number 3 after we open the brackets. Okay? And here we have plus 2xmn minus 2x plus 2xmn minus 2xmn is 0. So those two expressions will get cancelled. And in the next step, we took out d squared as a common factor from this expression and also from this expression. Therefore, inside the brackets, we have m plus n. Then we took m times n, we took out m times n as a common factor from this expression and from this expression. So inside the brackets, we left with m plus n, and it must be equal to mb squared plus nc squared. Then we took m plus n, we took out m plus n as a common factor out of those two expressions. So inside the brackets, we left with d squared plus mn. And it is equal to b squared times n plus c squared times n. Here we already found out that according to the drawing, n plus n equals to a. So we can substitute m plus n by a. We substitute m plus n in this equation by a, and found out that a times d squared plus mn equals to b squared m plus c squared n. And this is exactly Stewart's theorem. Okay. Then in the next step, we proved Stewart's theorem according to the second method. In the second method, we defined angle ADB as theta. Therefore, the adjacent angle ADC must be equal to 180 degrees from theta, according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. You can see that in the upper side of the straight line BC on point D, 180 degrees minus theta plus theta equals to 180 degrees, exactly according to rule number 1. Then we implemented the Pythagoras theorem on the green triangle, and we implemented the law of cosines on the green triangle, and then in the pink triangle. What is the law of cosines? This is the law of cosines. The law of cosines is true in any triangle. According to the law of cosines, so this triangle, triangle ABC, could be any triangle. The length of side AB is A units, side AC equals to B units in its length, and side BC equals to C units in its length. Then according to the law of cosines, c squared, and here angle BAC equals to theta, of course. So according to the law of cosines, c squared equals to a squared plus b squared minus 2 times ab times cosine theta. From this equation, it is very easy to arrive to this equation that cosine theta equals to a squared plus b squared minus c squared over 2 times ab. And we implemented the Pythagoras theorem in the green triangle, ABD. According to the law of cosines, cosine theta equals to m squared plus d squared minus c squared over 2 times md. Repeat again, according to the law of cosines, cosine theta equals to d squared plus m squared minus c squared over 2 times dm over md. Then we implemented the Pythagoras theorem of the pink triangle, triangle ADC. According to the Pythagoras theorem and according to the law of cosines, cosine 180 degrees minus theta equals to d squared plus n squared minus b squared over 2 times dn. Repeat again, in the pink triangle ADC, cosine 180 degrees minus theta equals to d squared plus n squared minus b squared over 2 times dn. We have the trigonometric identity that states that cosine 180 degrees minus theta equals to minus cosine theta. Therefore, we can substitute cosine 180 degrees minus theta in this equation, equation number 2, by minus cosine theta. We did it here, and we found out that minus cosine theta equals to d squared plus n squared minus b squared over 2 times dn. In the next step, we multiply this equation, equation number 1, by minus 1. So minus 1 times cosine theta equals to minus cosine theta, and then we multiply this side of equation number 1 by minus 1. So it is minus d squared plus m squared minus c squared over 2 times dn. So we have cosine theta according to equation we have minus cosine theta according to equation number 1, and we have minus cosine theta according to equation number 2. And then we created equation number 3 that states that minus cosine theta according to equation number 1 must be equal to minus cosine theta according to equation number 2. Okay, very simple. Minus cosine theta according to equation number 1 is equals to here d squared plus m squared minus c squared over 2 times dn. And it must be equal to minus cosine theta according to equation number 2. Minus cosine theta according to equation number 2 equals to d squared plus n squared minus b squared over 2 times dn. Then we multiplied this equation, equation number 3, by 2d. And here we have 2d over 2dm. So 2d over 2d is 1. So 2d will get cancelled. And in the denominator, we left only with m. Okay, here we have m in the denominator. The numerator didn't change. And here we multiply this side of this equation, equation number 3, by 2d. So 2d over 2d is 1. So in the denominator, we left only with n. In the denominator, we left only with n. The numerator didn't change. So in conclusion, we found out that minus d squared plus m squared minus c squared over m equals to d squared plus n squared minus b squared over n. Then we cross multiply this equation, equation number 3, and we found out that minus n times d squared plus m squared minus c squared equals to m d squared plus n squared minus b squared. Then we opened the brackets on both sides of this equation, equation number 3, and we found out that minus n times d squared is minus n d squared, minus n times m squared is minus n m squared, and minus n times minus c squared is plus nc squared, because minus times minus is plus. And it is equals to m times d squared is md squared, m times n squared is n squared, and finally m times minus b squared is minus mb squared. Then we added to this equation, equation number 3, nd squared. So nd squared minus nd squared is 0. We added also nm squared minus m squared is 0. And we subtracted nc squared from this equation, equation number 3. So nc square minus nc square is 0. So in this side of the equation we left with 0. In the other side of the equation we have already have here md square plus md square. In this side of equation number 3 we have md square, we have here md square plus mn square plus mb square, md square plus mn square plus minus mb square. So we added nd square to this equation, then we added nm square, then we subtracted nc square. So this is equation number 3 after we did the operation. And then here we took this square, we took out this square as a common factor from nd square and from md square and from nd square. So inside the brackets we left only with m plus n. And then we took mn, we took out mn as a common factor from nm square plus nm square. So inside the brackets we left with m plus n, and it is minus mb square minus nc square, that is equal to 0. We subtracted mb square and also nc square from this equation, equation number 3, and found out that according to equation number 3, d square m plus m, n plus n, plus mn times n plus n equals to mb square plus nc square. Okay, then we took we took out m plus n, we took m plus n, we took out m plus n as a common factor from those two expressions. So inside the brackets we left with d square plus mn, and it must be equal to b square m plus c square n. Then we have already found out that m plus n equals to a. Here m plus n equals to a, therefore we can substitute m plus n by a. So we substitute m plus n by a in this equation, equation number 3, and found out finally that a times d square plus mn equals to b square m plus c square n. So we proved Stewart's theorem in 2 different methods. Okay, thank you very much.